Hello friends, welcome to the third lecture of digital communication. Moving to the next topic, let's have a quick revision of our previous lecture. In previous lecture, we have studied that why sampling it is needed, what is sampling theorem, and what are the different types of sampling techniques are there. As like your ideal sampling it is there, natural sampling it is there, or flat top sampling it is there. After sampling, we have seen quantization, that what is quantization, what are the types of quantization, uniform, non-uniform quantization. Then again in non-uniform quantization we have seen two types, mid-trade, mid-rise, how this non-uniform quantization it is going to be achieved through compounding like that one. After that, we have seen pulse code modulation, that what is pulse code modulation. And today we are going to see that what is delta modulation. Now, if we have seen the pulse code modulation, then why there is a need for this delta modulation? Then definitely pulse code modulation, it has some drawbacks. So what are the drawbacks of pulse code modulation? Basically, in pulse code modulation, the signaling rate and the transmission channel bandwidth are quite large because it transmits all the bits which are used to code a sample. So due to which bandwidth requirement and signaling rate it is very high. In order to overcome this problem, we are going to use delta modulation. Now, what is the principle of this delta modulation? Basically, delta modulation, it transmits only one bit per sample, and here the present sample value is compared with your previous sample value, and their result, whether the amplitude is increased or decreased, that is transmitted. Input signal x of t is approximated to a step signal by this delta modulator, and the step size is fixed. Now you can see on this screen that this is your x of t, that is original signal, and which is approximated to this staircase signal. And you can see this step size is fixed over here. So the difference between your x of t and your approximated signal, it is confined by this delta, that could be plus delta or it could be minus delta. So if it is a plus delta it is there, then what is going to be happen? The step size is increased. But if it is a minus delta, then it means, what does it mean? The step size is reduced. So if step size is increased, then we are going to transmit binary 1. But if the step size is reduced, we are going to transmit what? Binary 0. So in this manner, in delta modulation, we are going to transmit only one bit per sample. Over here, u of t is nothing but your approximated signal. Now, we will see the mathematical expression of this principle of delta modulation. Now, the error between x of t and this last approximated signal is given by E of NTS, that is error. What is it? That is x of NTS minus x dash NTS. Now, what is E of ENTS? It is nothing but the error at present value. And what is x of NTS? It is nothing but a sample value, sample signal of x of t. And x dash of NTS is nothing but your last sampled approximation of staircase waveform, or we can say what? Previous sample. If we assume that u of NTS, as we have seen, u of NTS is nothing but your approximated signal. If u of NTS it is going to denote, or we will assume as a present sample approximation of the staircase output, then definitely u of n minus 1 ts is equal to x dash of nts, because x dash of nts is nothing but your last sample approximation of your staircase waveform. So that's why u of n minus 1 ts is equal to x dash of nts. Now let us define a quantity called b of nts in such a way that b of nts is equal to del of sine e of nts. It means depending on the sign of this e of nts, the sign of step size delta is decided. In other words, we can say that b of nts is equal to plus del, where if x of nts is greater than or equal to x dash of nts. It means that present sampled value is greater than or equal to previous sample value, then we are going to transmit plus del, and b of nts is minus del. It means if present sample value is less than or less than to its previous sampled value, that is x dash of nts. In another way we can write it, if b of nts is plus del, then binary 1 is transmitted, whereas if b of nts is minus del, then we are going to binary 0 is transmitted, and ts is nothing but your sampling interval. Now on the screen you can see that there is a transmitter of delta modulator. Basically it consists of accumulator. In accumulator there is one summer and where there is one delay block it is there. There is a second summer which is going to add the sampled input and its previous approximated signal, which generates nothing but your error, and this error it is going to give it to your 1-bit quantizer, which is going to generate your plus del or minus del. Now it consists of 1-bit quantizer and a delay circuit along with this 2 summer circuit. The summer in the accumulator, it is going to add the quantizer output that could be plus minus del with this previous sample approximation. This previous sample approximation, it is nothing but u of n minus 1 ts. So what is the present sample approximation? It is nothing but addition of your b of nts and u of n minus 1 ts. So the present sample approximation is equal to u of n minus 1 ts plus b of nts. Now this previous sample approximation is restored by this delay element whose sample period is what? T of s. This sampled input x of nts and its staircase approximated signal both are subtracted to get what? Error signal E of nts. Thus depending on the sign of this E of nts, this 1-bit quantizer, it generates an output that could be plus del or minus del. If the step size is plus del, then we are going to transmit what? Binary 1, and if it is minus del, then binary 0 it is going to transmit it. Moving towards a delta modulator receiver, it consists of accumulator and low pass filter. This accumulator, it is going to generate this staircase approximated signal output, and it is delayed by this block by one sampling period ts. Then it is added to this what? Your input signal, and if the input is binary 1, then it is going to add plus del step to the previous output which is delayed over here, and if the input is 0, then one step del it is subtracted from the delayed signal, and This low pass filter, it nothing but it smoothens the staircase signal in order to reconstruct the original signal x of t. Now, what are the advantages of delta modulation over PCM? Since delta modulation, it transmits only one bit for one sample value. Therefore, the signaling rate and the transmission channel bandwidth is quite small for delta modulation as compared to PCM. The transmitter and the receiver implementation is very much simple for delta modulation, and there is no need of analog to digital converter required in this one. Now moving towards one of the most important factors of delta modulation, it is the disadvantages of delta modulation. Now what are the disadvantages of delta modulation? From the figure you can see it that the rate of rise of signal is very high. See, this is x of t, and the rate of rise of this input signal, it is very high, so that this staircase or approximated signal, it can't approximate it, it can't properly follow this one. So this step size, it becomes too small in order to follow this x of t. So due to this, what is going to be happen? There is a large error between this staircase signal, approximated signal, and the input signal. So this error or noise is called what? Slope overload distortion. Now, how to overcome this one? So to reduce the error, the step size must be increased when the slope of x of t is very high. But problem with delta modulation is that step size is constant. So that's why this slope overload distortion we couldn't overcome in delta modulation. Now moving to the second disadvantage of delta modulation is what? Granular noise, or we can call it idle noise. Basically, it occurs when the step size is too large as compared to this small variation into this input signal. You can see from the figure that since this x of t, there is a very small variation, or we can say it is a very flat, but still this approximated signal, it is hunting on that one. So for a small variation in input signal, the staircase, it is going to be changed by large big step. So due to which, what is going to be happen? This staircase keeps on oscillating around the signal with plus minus del. So the error between your input signal and your approximated signal, it is called what? Granular noise. So how to overcome this noise? In order to overcome this granular or idle noise is to make this step size very small. But as we know that since it is delta modulation, and in delta modulation the step size is what? It is fixed, it is constant. So that's why we couldn't avoid sloped overload distortion as well as granular noise in delta modulation. Now, in order to overcome this problem, we are going to see now the adaptive delta modulation. From the name suggests, as its name suggests, the step size is made adaptive because it is adaptive delta modulation. Why we are making the step size adaptive to it? To the variation of this input signal, in order to avoid this quantization error that is called a slope overload and granular noise. Particularly in the steep segment of signal x of t, it means the rate of signal of x of t is very high, then step size is need to be increased, and the step size is need to be decreased when there is a very slow variation in the input. So which is possible in this what? Adaptive delta modulation. Now on the screen you can see ADM transmitter. So if you will observe all the block of this ADM, it is similar to your delta modulator. So what is the difference? The difference is that the addition of this logical block in order to control the step size. The step size, it could increase or decrease according to the specified rule depending on this 1-bit quantizer. Now suppose if 1-bit quantizer output it is high, if 1-bit quantizer output it is high, that is binary 1, then the step size may be doubled for the next sample, and if 1-bit quantizer output is low, then the step size may be reduced by 1 step. So this same you can see on the screen, that see here how the step size it is going to double depending on the input. So it means the step size are adaptive to this variation, high variation in your input signal, and when the variation it is going to be slow, it is low, then delta or step size they are going to reduce it. See, there is a small variation in this one. So in this manner it is called what? Adaptive delta modulation, and we have overcome this slope overload distortion which was present over here in delta modulation and granular noise that is presented at delta modulation. So you can see that if the step size is going to increase, then binary 1 it is going to transmit. But if the step size is going to reduce, then binary 0 is transmitted. Now this is ADM receiver. ADM receiver, basically it consists of 2 blocks. First is, the first portion is, you can see it is going to produce the step size from each incoming bit, and exactly the same process which happened at in your transmitter. The previous input and the present input, now they are going to decide what? The step size, and then it is applied to a second portion that is called accumulator, which builds up staircase waveform, and the low pass filter it smoothens out the staircase waveform to reconstruct the original signal. Now what are the advantages of adaptive delta modulation? The signal to noise ratio of adaptive delta modulation is much better than that of your delta modulation. So because of the reduction in your slope overload noise and granular noise, which is also called as idle noise. Because of the variable step size, the dynamic range of adaptive delta modulation is much wider than your delta modulation, and the utilization of bandwidth it is also much better in your adaptive delta modulation. Now, so up till now we have studied that what is delta modulation. In order to overcome the disadvantages of pulse code modulation, we have seen delta modulation. But delta modulation, somehow it has overcome the disadvantages of PCM when transmitting only 1 bit per sample. But there are disadvantages of delta modulation, that is of slope overload noise and granular noise, because the approximated signal it couldn't follow the high rate of input signal. It couldn't increase its step size in delta modulation. So that's why there is a huge gap between your x of t, that is input signal, and approximated signal. So due to which what is going to be happen? Slope overload noise it is occurred. Whereas in granular noise we have seen, although the variation in input signal it is very low, but still that approximated signal it is oscillating by plus and minus del. So again it is going to generate what? Granular noise. So we have seen in order to overcome the disadvantages of this delta modulation, adaptive delta modulation it is there, because there is a logic that it is going to adapt its step size. It is going to double its step size if the input is 1. If the previous input it is 1, and then again if the input it is 0, then it is going to reduce its step size. So in that one, somehow we are going to overcome the disadvantage of slope overload distortion and granular noise. Now here it is an assignment for you. So you have to solve this assignment and you have to submit this assignment. So please note down these questions. In next lecture, we are going to see that what is differential pulse code modulation, or why we require this differential pulse code modulation. And for speech, for music synthesis, basically we are going to use what? LPC, that is a linear predictive coding speech synthesis. So up till now, if you have any questions or if you have any feedback, you can mail it on my mail. So here it is all about today's lecture. Thank you very much.